Hi everyone, and I have some issues here. Oh,
You want me to share again?
no, it's fine. I was playing
Okay.
the stream also on another page. Hello everyone, and welcome for another episode of AI Talks Live. We had a little break yesterday last week we didn't have a talk because of some circumstances, but hey, we're back today. Today we're having Patricio Cofre, and he will be talking about reinforcement learning with cognitive services. So we're also looking forward to that.
Hey, my name's Akanksha Malik, and I'm from Melbourne.
Exit Summit, it's Val here.
Hi, I'm Alan Smith.
Hi, I'm Amy.
Hey, I'm Tess. I come from Spain.
I'm Prasant from California.
大家好，我是卢建辉。
My Nederlands. I'm Fakasi from Australia.
Hi, I'm Jennifer Marsman from the United States.
Hi, I'm Arpita Gupta from India.
Hi, I'm Matthew Renton from the USA.
I'm Joe Spizak from California. Hi, Medine Eddie Daoud from Africana.
Hi, I'm Ana Famana.
Merhaba, ben Türkiye'den Daron Gönder.
Hi there. Hi.
Hi. Hi.
Hi.
Hi.
So here we are, Patricio. Thanks you for joining us today, all the way from South America.
Yes, thank you so much for inviting me.
How are you doing?
I'm fine. Fortunately, starting the summer here in Latin America. Fortunately, COVID is we are leaving the first wave. Hopefully, the second will be hopefully delayed.
Well, we hope everyone of our community can stay safe in this difficult times we have at the moment. But Patricia, for the people who do not know you, who are you?
Well, okay, so my name is Patricio. I live in Santiago, Chile, here in Latin America. I started a company in data and analytics, doing a very nice project here in Chile and Argentina, Peru, and all the countries here around. At the end of 2019, my company was acquired by Ernst & Young, and now I'm partner of the firm. So I'm very happy to have done this switch. We are now facing a larger project, so I think this was a good news for us. And also, well, in 2016, I became a AI MVP, initially in data platform. Then I moved to AI, and probably that's why you invited me.
That's indeed one of the reasons. What is your day-to-day job?
Well, it's basically the business consulting. We are doing consulting for large clients here in Latin America, helping them to transform to a more digital way. We are working with the governments. We're working with large retailers, banks, and so on, and putting a lot of Azure actually in the market, and trying to get ready to keep up with all the new releases and things. So my team is fortunately is very excited about the new releases. It's always researching and doing cool demos that I use in these opportunities.
That sounds like a cool job. So your session that you want to share with us?
Sure.
About reinforcement learning with cognitive services.
Yes, actually, what I've seen in the market that still AI is focused in the supervised learning a lot. But one common question from clients is, what if I don't have data? What if my data is too bad? Or what if things are changing too fast, that my old data, for example, pre-COVID or COVID data, should be used in my model. So that's where I started researching the reinforcement learning, because of this eventual no need of historic data. You just can start creating, and that's things that I'm gonna cover in the slides.
Okay, cool. So I'll give you the platform if you share your slides with us.
Excellent. There it is.
We can see your screen.
Excellent. Okay, so thank you again, Sami. Thanks everyone who have connected to the show. As Sami said, I'm going to talk about reinforcement learning into the Azure context. Actually, there's a new cognitive service called the Personalizer cognitive service that I'm going to try to focus. However, I think I'm gonna try to start from the principles, trying to understand what is reinforcement learning, and then dive into Azure and finally into this new cognitive service that is now available, and we can start using with clients. Okay, so this is my agenda. I'm gonna try to start from these principles of what are the types of machine learning. Then I'm gonna dig into reinforcement learning specifically. Then we will talk about personalization as a big enterprise issue, what the clients are asking and why they are need to personalize experiences, especially now that we are much more digital than we used to be. And finally, I'm gonna talk a little about the personalizer and jump to a couple of demos. Okay. So, first, starting from the beginning, artificial intelligence is every time that we try to create a machine that imitate any cognitive function. And when we say cognitive, we mean typical things that we as humans can do pretty easy, like learn, solve a problem, to see, to smell. And when we are providing these abilities to a machine, this is the whole, the big issue around the artificial intelligence. And into artificial intelligence, you'll find that there's one subset, which is the machine learning, that we hear a lot. That is the case when we try to do these things to embed cognitive functions into a machine, but using a history of data and statistical algorithms. Okay, so every time that we use a statistical algorithm that learn from data, we're gonna be speaking about machine learning. And there's one subset into the machine learning, which is called the deep learning, that which is the case where the statistical method is one in specific that have grown a lot in the last 4 years, and definitely is the responsible for the big momentum that AI is getting, which is the deep learning, and that use the multi-layer neural network, right? So once at the time that we solved and we became familiar with training multi-layer neural networks, we are talking about deep learning. Now, regarding the types of machine learning, probably you have talked about it previously, but in supervised learning, it's all the time that we have data and labels. So we have data itself, that is the whole context that we are seeing. If this is an IoT scenario, if this is a retail records scenario, or in this case that I'm showing here, which is a picture in which each pixel is at least 3 points of data. So we have a lot of data itself is the core of the situation we are getting, but we also do have a label. So in the first 4 cases, this is a dog. In the last 4 cases, this is a cat. So I do have this relationship. In the name supervised actually came from this thing that there's a label that supervise if our learning is doing good. So by looking at the past with the labels, we can see, okay, our algorithms or our models have been trained in a good way. Are they fitting well or not? And that's why this is called the supervised learning. Is the most common that we see in the use case that we used to see. Okay, Then there's a second type of machine learning, which is called the unsupervised learning. And as the name said, we do have a lot of data, but we do not have labels. And this there are many scenarios in which you can find a lot of data, but you don't have a label. This can be because we are not measuring something, or because we have not done the manual process of tagging, like when you see the dog to manually tag, this is a dog, this is a cat. So eventually you will find these cases. The good thing is that these types of algorithms are very appropriate in some scenarios. For example, if you see the animation in the right, these are all the handwritten numbers, and we will be considering data, the whole set of pixels of this small image containing a number, and we do not have the label. I don't know, this is a 5, this is a 3, this is a 7, and so on. But we put this into an unsupervised learning that will group somehow, by doing a lot of internal mathematics and so on, that eventually will group things that are very similar. So as you see, the number 5s tend to be very close, the 7s are all close, the number 1s are all close. Eventually there are some mistakes, right? Because some numbers tend to can eventually see very similar, but they do not. So what's the good thing in here? That eventually there's one label that we are not aware that it exists. For example, what happens if a letter get in? If a letter get into the numbers, eventually we will find that the unsupervised learning will find a new cluster with this letter. Or going back to the previous example, what if the universe is not only 2 animals, dogs and cats? What if there's also elephants? What if there are also turtles? And they are part of my data set with supervised learning. And if we believe there's only 2 layers, they will see a turtle, and they will try to see, is more a cat or more a dog? But this is all the supervised learning can do in that way. But in unsupervised learning, eventually the new category, the new label, will show up in a new cluster, so we can dig in here, understand, and create a new insight that, wow, the world is composed of more than 2 animals, right? This is pretty useful, for example, in banking, when looking for fraud and any misuse or spam, because you never know the whole set of spam, the whole set of types of cybersecurity issues, the whole set of fraud, right? And eventually, if there's a new way of fraud showing up, eventually the unsupervised learning will show me a new cluster that I can research with more detail and try then to stop it, right? And finally, and this is the point where we were going, in reinforcement learning, we have no data and we have no labels. So this will be inspired in behavioral psychology, and will create an agent trying to do some movements, initially random, and then by using some optimization technique, that will get a reward if he reach the behavior I want. For example, this small dummy here is called the Mojoko from OpenAI. This is a small biped that they have their that can bend their knees, can have all these articulations, and he will start doing some movement, even initially random, and I will give a reward if he stands. That is the goal in the situation, right? So that's why we don't need data, because the experimentation is done by itself. It's the same dummy that will try to will experiment. So in these cases, what we will need is a simulator. right? So from a simulator, we can get data, and from the data, start doing some learning. And this is actually the algorithms or the type of machine learning behind AlphaZero that probably you have known, you have seen in this big milestone of the artificial intelligence that happened last year, or in 2016. I'm sorry, that created a great path for artificial intelligence. Okay, so we without data, only with the game playing itself, we can create the data and start the learning process. Okay, so as a summary, in supervised learning, we have labels, we have data. In unsupervised, we have data, and we do not have labels. And in reinforcement learning, we don't have data. We don't need historic data. We need data, but we don't need a previous historic data, and we do not have labels. And we will replace somehow by this concept of reward. Okay, so let's go to reinforcement learning. Well, reinforcement learning will be the set of techniques that allow AI to experiment with the universe, experiment with the world, try some things, and then see what happens, right? So we'll give the capacity to a machine to experiment, to do something with the context, and then read back some reward to see what happened with the world once I did some movement, right? So this world can be the world itself. I mean, if we are trying to do robotic, we have two chances. We can experiment with the robot itself, right? Or we can work with a simulator of the robot, right? And this is pretty interesting because with the robot, eventually we have some hazards. Eventually, the robot will do very hard movements and eventually will break. So that's why it's highly recommended to start working with simulator and then move to the physical robot, right? So the whole learning occur in a simulated way where you can also stress the training by putting very difficult situations, trying to simulate the harder scenarios and so on, and then go back to the arm that will be very robust in doing things. Okay. So in reinforcement learning, one interesting thing is that there is that a percentage of the time this reinforcement learning engine will be exploiting the best knowledge he have, but the rest of the time he will be exploding. And this is interesting because a proper reinforcement learning machine is always learning, is always spending a percentage of the time, let's say some 20% of the time, will be exploring new things. Why you need to keep exploring? Because the context keeps changing and preferences keep changing. So as you see, we can explore to try new alternative. Initially, everything will be exploding because we have no current knowledge, right? So initially will be 100% exploding. Eventually we will get to a knowledge and it will become our best inferences and we will start exploiting. So eventually at the end, my recommendation and the recommendation is to start putting a larger percentage into the exploit zone, let's say up to 90%, and never put explore to 0, because it's always good to have one ear listening to the world, how it changed, how things are changing. For example, if there's a trending topic, for example, it can eventually learn it. It can eventually unlearn it in the time. So that's why it's important to put this explore side always on. This is an example just to visualize how it works. Let's think on a coffee shop that a user comes and requests a coffee or a tea. You can do your bot or whatever you want, but at some point you will make a call to the personalization service, and this call will include first the context And the context means from what device is the user coming from, what are the referrals, how much battery he have left, in any context information, even the weather, if you want. You can put as much context as you want in the context zone, and then you need also to give to the personalization service the options you have. The options in as much information from these options that you have, you call to this rank function and go to the personalization service. Then the personalization will come back with the 3 options, but ranked, right? So we can understand that Mocha have a higher ranking, so my app or my bot can go back to the client and say, would you like a Mocha? And given the feedback that the user gives us, if this is a yes, we can go back with a reward of 1, or this is a no, we can go with a reward of 0, right? So he will be learning how context and options combine themselves by doing a lot of experiment initially, and eventually get to a new learning that create this intelligence for you, okay? One second case is, for example, imagine any digital situation like a music stream, video stream, or a game, or so on. Eventually, you'll at some point you need to show, or the game ended, and you want to show something to the user. You need to personalize experience, and you want to be proactive and show interesting stuff to your users. So you can ask, what can I show? What can I give back to my users? Okay, so the user have a lot of context, have a location, have with whose friends she was playing with, the signal, how long she has been playing, and so on. So there's a lot of context, okay? And we do have options like play again, watch a video, or join any social. Let's say that this is the whole set of options that I have. But also these options have some info, okay? Like what's the main color, what's the action about, how long it takes to do the action, and so all metadata you can add from the option itself is also useful. And as we saw, the rank function is called by using the context, but also any information we have from the options we have. So we give it to the personalizing service. It will go back with the highest ranking. In this case, is join. We'll show it to the user, and the user will give us some feedback. Eventually, will be if she clicked on the button, or how long it took her to click the button. So this is why you can put your own business logic. So the personalization service is not willing to collect automatically. You can add a business logic, and asynchronously, you can go back to the service giving what was the reward of the last recommendation you gave me, right? This is more or less how it works, okay? Let's talk a little about personalization. This is a big issue in current times, since we became more digital. Personalization is a big topic in businesses. We need to create more interesting digital experiences, and personalization is critical on it, right? So, for example, in this case, Paula is watching an original series on a weekend on home, in a tablet, in horizontal mode. So there's a lot of things you can infer from the situation. But Susan is probably at the same time is watching a documentary from a phone. She seems to be commuting. She's with headphones on. She's in a small device, probably not in a Wi-Fi network. So the context matters. So why should we provide the same content to both of them? Yeah, we have enough context to see. We have enough original content to show. So why don't we start improving the matching of the context with the options, but not through an expert mode, but by a pure black box artificial intelligence trying to do the match. This is the main goal of reinforcement learning and personalization itself, right? And the good news is that personalization has proven to give a return. Okay, so this is a study from McKinsey and Microsoft that customer satisfaction are 20% up after using personalization or embedding personalization in our website, apps, or chatbots. Revenue can increase between 10 and 15% as the study shows, and we can also reduce costs between 15 and 20% because of this new understanding by providing the best content back to our users. Okay. And even though personalization seems to be a very, very hype topic, 81% of executives think that they will soon be competing only through digital experiences, right? So since we became more digital and now we're competing for digital assets and digital experiences, 81% of the executives think that the best way to compete in a market will be experience, right? But only 22% of the same executive think they are currently providing an experience that exceed the customer expectation. So this is the gap, and this is the space for a service like the demos that I'm going to show you. Okay. Why we need this? First, because context is always changing. Context is dynamic. Interests are changing because things are more novel, things are more popular, things became viral, for example. The behavior is also getting more complex. There are different devices connected. You can be in very different contexts with a more or less battery level, with more or less Wi-Fi signal, etc. And also there's a lot of content that we have not exploited all the information it have. Like, for example, what's the visual style? What are the main color? Are some color, for example, more likely to create a better funnel to create purchases? So are some layout of the web page better to improve our funnel in an e-commerce setting? So these are the kind of questions that we don't need to completely understand. We don't need to create hypotheses and tons of hypotheses to try to see what's the good match. We can also leave this reinforcement learning technique to start learning from this. But we need to provide metadata from the options we have. Okay. At this point, it might sound like A/B testing, right? And this is something that probably you have seen in the past. A/B testing, basically you start designing one experiment, then you do first you design the experiment, then you run the experiment by flowing 80% of your clients and experiences through the version A, 20% into the option B, and eventually you will learn that version B works a little better on time of stay, on funnel conversion, and so on. And then we need to start over. So we are somehow testing one idea or one hypothesis at a time. In reinforcement learning, the good thing is that the model itself will be exploring opportunities. So the same model will explore a new version. The same machine learning will try to do a movement and then try to get a reward. So the process start working automatically with not only by choosing one hypothesis to test, is testing hundreds of thousands of hypotheses right? Because it's on each experiment, he can try a new thing, he can try to find a new match, and the model start working by itself. Okay, so this is more or less the comparison with A/B testing. Okay. So now let's see the personalizer itself. First, we can get contextual engagement across the whole customer journey, because this is always hearing, this is always sensing, is seeing how your context is changing, and eventually it will change the content that will show to you. The Azure Personalizer service works through two APIs. Is that simple. The first is the score API, where we get a recommendation, and then is the rank API, where we asynchronously go back with the reward that we get from the previous action, or from a previous action. We can leverage the context much better, and we can use our own logic in sending back the reward. Okay, so the reward is not necessarily money, it's not necessarily a conversion. It can be the KPI that you best choose to try to get a behavior. For example, in the small little in this small dummy, the Moyoko, we want him to stand. But eventually, I will try to pursue a different goal, like to sit, for example, right? So this KPI is in our control. We choose how to give reward, and we just need to program how to do it. Okay, so in general, and this is a more general context, a user interact with an application or a site. We do have some options for him, like the circle, the square, and the rectangle. We call the rank functions with the context and with the actions we have. The inference or exploration policy will give me inference in case of the best knowledge, exploration in case of exploring, will give me a rank of the options given this context. We go back to the user, and the user display a behavior that we will measure somehow through our code. So this is how we code the reward. And let's say we will collect a 0.8 reward. We go back to the personalization service asynchronously, and there will be a joining engine that will match, okay, this reward corresponds to this recommendation I did. This join, create a log, go back to training to train a model, and this get to the brain back. Okay, so this is how the whole thing works. How much of the time is doing inference is just one setting that we need to provide to the service. I'm going to show it to you later. Okay, so here it is. This is the setting screen, and as you see, the first setting you are prompted to do is the reward wait time. So how long will we wait for the reward? Otherwise, we can put a default value like 0 or earliest, right? So it's important to set how long will you wait for the reward. In this case, 15 seconds, can be 1 hour or whatever, depending on the use case. Then is the parameter that I was telling you, how much of the time you want it to keep exploring, right? So at the beginning, probably you will put 100%, but with the time, as the engine become more intelligent and keeps gathering patterns, you can go back to a 20% or at least a 10% in order to keep some space for to finding new things. And finally is the model update frequency. So this is collecting a log, and eventually you want to retrain the model. So you don't have to do the whole data science to do the new model. It will do by itself by doing the internal deep reinforcement learning that a personalizing service have, and you can keep going. Other good thing is that the same personalizing service gives you back a report that show the efficiency of the model. So you can compare with a baseline or a random suggestions, and we can see how the reward is increased by using the service instead of using an heuristic or a random selection, right? So this is money, right? If your situation is an e-commerce, it's more sales. Or if this is an ad, you get more clicks, right? So the difference usually is money. And finally, and this is a good thing that Microsoft is putting a lot on the new releases, are this feature explainability, right? So in order to give an explainable AI, even though this is a black model, they are also showing us what are the features that are more effective, the features that are less effective, so we can understand somehow what's happening behind, okay? So let's jump to the demo. I'm gonna jump to Visual Studio. Sammy, you still see my Visual Studio screen?
Sweet. Yeah, we can still see.
Excellent. Okay, so here is loading the first demo. Okay, this is a standard demo. It do have a lot of code, but it's mainly the screens and so on. And here in the app settings, you'll find that you are prompted to put first a personalization endpoint, which is the cognitive service of personalization. And also, this is asking me for a text analytic endpoint. Okay, and I'm going to show you why I'm putting this also this text analytic endpoint. Okay, so this is all you need is you just need to put reference to this endpoint that you create in Azure. Yeah, just going to personalizing service, create an instance, and it will give you this endpoint and some keys. Right, that my suggestion is not to put in the app setting. Put this is in a key vault or something like this, and by doing this, you can run the program. Okay, I'll run this app so you can see it. And this will show me an scenario where we need to recommend content for a situation. Okay, so in this case, it's a tennis blog or a tennis web page where the main banner, I want to personalize it. So I define that this banner will get something for you, given your context, given where you come from, given this how's the weather where you are. So I want to show all the people a different thing on this banner. Okay, so I'm gonna click on show a personalized article, and got it. I got this article, and let's see how it works. What do the website knows about me? And as you see, the website note where you come from, or this what was your referral. You came from a social media, you get direct to typing the website, you get through an email, you get to a search engine. What's the ongoing tournament? Okay, so now it's been playing the Australian Open, for example. In what device are you clicking from? In this case, I'm in my desktop. Okay, so I'm going to ask for a new personalized article, and it gave me the same one, and I'll keep clicking. So eventually there it is, and eventually I'll get a new recommendation. Got it? So this reinforcement learning engine is seeing my context, and this is the context that I'm allowing it to see, but eventually I can give an extra content. And let's see, if I click on use the user agent, see how the context that used to be direct Australian Open and desktop, now it can be enlarged to that I'm using a Windows 10, that I'm using Windows, and I'm in a desktop device. Right, so I increase the context that I'm gathering, and eventually recommendations will become better. And but also, as you remember, one thing is the context, but the other are what are my options? What are the digital assets I do have to show in this banner? So in this case, I do have three news. One from Serena Williams, the other one that is showing up right now, and so on. And for each of these options, I do have some metadata. Like, for example, this new came from watennis.com. It has a video equal true, published ago 1 and 2 months, and some metadata, right? But what if I click on add extra features with text analytics? So it will not only look at this metadata, but it will go to the data, to the text itself, and it will add several new features like key phrases, all these key phrases, kind, way, blah, 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 and a sentiment. So in this case, it's a very positive new, right? But eventually I'll click some of the others. This is positive as well, and this is positive as well. So we added new data to describe new features for the options we do have, right? So so let's see, I'm going to keep asking for recommendations, and eventually I get this one. Eventually I will click on, right? And this might be translated as a reward if you want. So you can put a reward of 1 because I clicked, but you can also be a little bit more strict and try to or probably you want something else, not only the link. And in this case, look at the reward, and the reward will be gained as far as oops, no, something is not working here. I'm gonna go back. But I gave the reward, there it is, in how much I scroll on the web page. So this is, I created this KPI. I created this code to see that the reward will be not only to click, but how far you went into the article. So in this case, I go back and I collected a reward of 1 because I read the whole new, right? Or eventually a different one. Okay, I stopped. I didn't like it. It's not what I want, and I go back. So I collected a reward of 0.7, right? So we have this full flexibility. And let me show you just one more example where you'll see the whole flexibility we have to choose this reward function. I'm going to jump to this one. Okay, so same thing. I do have this app setting. In this case, it's only using the personalization endpoint. I don't have text in this case, as you will see. And I'll run the program. Yeah, I run my website. In this case, we are simulating a travel agency, right? And the object that we will be experimenting will be a banner as well. But as you'll see, we completely change the reward function. We choose a very, very different thing to determine how much reward we'll collect. Okay, so eventually at the end of a whole client journey, he will choose a couple of options, and we can go to checkout. And into the checkout, look, it's showing me one image, and look at the conversion reward. It's already going down. So what I'm willing, I want him to click buy now as fast as he can, right? So in this case, I got 0.7 because it took me some time to decide, or right? I'll restart the demo. I'll go back. I'll ask for a new recommendation. I'll do it a few times. So eventually it will give me some a different banner. let's click here. Let's change a little the context, right? And I'll go back, go to checkout. I'll do it two more times. Let's see if it changes. It's not changing too much. Okay, it's always giving me the same. Probably I need to mix this a little bit more. Okay, but let's think on a situation where I see the web page and I decide no, I'm going to save for later.
Patricio, it's not the picture that is changing; it's the title.
Ah, got it. Yes. Yep. Yeah. Yeah, but this is the point: is you can define by yourself how you will collect the reward. In this case, is a clock that is going back, depending on how long it took me to click on buy, which is the desired behavior, right? So if I put this save for later, I define that will be 0.2. No, nothing more, nothing less. Okay. So I'm going back to my slides, but I think yeah, there it is. So this is the demos I wanted to show you. I hope you enjoyed, and I'm here for your questions.
All right. Thank you, Patricio. So if you have any questions, please, you can use the chat on the globalai.live website, or on YouTube, or on Twitch. So many places where you can chat, but we keep track of all of it. I have one question, Patricio. So you have, would this work, for example, if you have, let's say, if you use it for a shop as a recommending engine?
Yes, absolutely. What Microsoft says is that you can definitely use it as a recommendation engine, but you can also couple this with your recommendation engines, because eventually a recommendation engine can take millions of SKUs, right? A million of items, and eventually it can narrow down to let's say 50. 20 options, and the recommendation engine can do the last mile of the recommendation. So it can also couple with your current recommendation engines, especially in the case that you have millions of items. In that case, probably this will not gonna work. This is thought to be, I don't remember if the maximum is 50 elements, I think.
Okay. All right. So that's something you really need to keep in mind, that you have a limit of 50 items. So you could say, for example, your 50 products that you have in promotion at the moment.
Exactly.
Okay, cool. We get some thank yous. A great session from El Bruno.
Excellent.
So there's no more questions at the moment. I think it was a very interesting session. I personally hadn't had time yet to spend some time in this service also. It's well, I think it's very useful. So yeah, thank you very much, Patricio. We have more people saying thank you. So we're glad we have some people watching live. It's always nice to have some live public who can ask questions if they like to. So if you still have a question, please don't hesitate to ask. We're still here. Next week, we have another session, and we will have Paul Peton, who will talk about automated machine learning, a game changer for data scientists. So also looking forward to that session. All right, no more questions are coming in. With that, Patricio, I will thank you for your time. I wish you a pleasant afternoon. For all the ones watching live right now, thank you for joining this week. Hope to see you next week again. And well, stay safe all. And we hope to meet you all soon face to face again.
Bye, Sammy. Thank you so much.
Bye,
bye everyone.
Hey, my name's Patricio and I'm from Melbourne.
Exit-Sami in Belgium.
Hi, I'm Alan Smith.
Hi, I'm Amy.
Hey, Neighbor Tess. I come from
I'm
Spain.
Prasant from California.
大家好，我是卢建辉。My name is Lance.
I'm Patricio from Australia.
Hi, I'm Jennifer Marsman from the United States.
Hi, I'm Arpita Gupta from India.
Hi, I'm Matthew Renton from the USA.
I'm Joseph Isaac from California. Hi, Mehdi Eddie Daoud with Ghana.
Hi, I'm Ana from London.
Merhaba, ben Türkiye'den Daron Gönder.
Hi.
Hi,